What do you learn about engineering and human error when your career begins with Apollo spacecraft and leads to solving some of the world's most complex accidents? Welcome to Industry Ignited. I'm your host, Dr. Leeanne Aguilar, and today I'm joined by Bob Swint, CEO of ATA Associates. With more than 50 years in forensic engineering and a 24-year NASA career that includes contributions to Apollo and Shuttle systems, Bob has become one of the most respected experts in accident reconstruction, system safety, and failure analysis. Bob, thank you for being here today.
Good. I'm looking forward to this opportunity. Thank you.
You're welcome. Now, you began your career at NASA during one of the most extraordinary eras in engineering history. What originally drew you into aerospace, and how did those early experiences shape the engineer and leader you became?
Wow, good question. What I started thinking as a young child, space. That was sort of the Sputnik world came alive, and had all kinds of information about space and science. And I sort of began early while I was in college and high school, just looking at the aerospace program, recognizing what the goal is and the challenges it was, and sort of focused my direction toward that. I went to an engineering school, went to West Virginia Institute of Technology. And while at school, I applied for the summer internship, and I got involved with going to Wallops Island, Virginia, which is a launch site for NASA. And I did that as a freshman and junior in college. Became very, very successful at learning science and engineering that was not something that you were taught in college. It was a much broader scientific field. So that helped me not only in college, but it also helped me through my life, because we saw the bigger picture. We saw the challenges. It was an interesting time frame, and everybody that was involved with that was dedicated. That was impressive.
Wow, yeah, very exciting. And that's a great opportunity. And how did you find that opportunity in college? Was it through people you already knew, or did you seek it out?
I started out by applying for a summer internship, and I was accepted. And I went, and it made me open my mind, because I had not appreciated engineering and the systems and the safety and aspects of space like I did as an intern. I was exposed to launches, I was exposed to range safety, instrumentation, and testing. That gave me a grounding that when I went back to college, went to school back, I was ahead of the game, because I saw what the answer was in the need for being more scientific, more overbroad look at things, not just centralized in a single area. So it helped me look at systems. It helped me look at the safety concept of the whole program, if you will. So it opened eyes that I didn't have before.
Right, yeah. And I know your work on Apollo and shuttle systems involved life-critical instrumentation and problem-solving under extreme pressure. What moments from your NASA years most defined your approach to identifying failures and preventing catastrophic outcomes?
Well, that career expanded over 24, 25 years. And during that initial stage, I was assigned to the instrumentation laboratories at NASA as a manager. And I learned that looking at instrumentation, how they were measuring all of these scientific issues on the spacecraft, structures, pressures, temperatures. And then as I became more knowledgeable, they assigned me the project engineer of the lunar module landing system and a DFI instrumentation. And we measured all the forces in the landing and looked at the crew. It's the first time I really looked at a total system, is how it would be operated and how it functioned. And that went further with the Apollo, where I was a subsystem manager of the command module. That's a command module that went into orbit and lands.
Uh-huh.
The concept of interior and design of the concept of the systems, switches, and controls. During that period of time, like on Apollo 8, we had a switching problem, which was associated with the launch escape system. We had to go, or I had the opportunity to go to the Cape, and they, on Apollo 8, 1.5 days before launch, we were required to go on the spacecraft and x-ray the launch escape system switches on a live spacecraft with x-raying. They cleared the pad. There was nobody, myself, a technician, and a laboratory guy from Cape. We were at the top of the Apollo spacecraft loaded with fuel, venting oxygen and hydrogen, X-raying these switches. And if we would have arced over the switches, we would have launched the spacecraft. We would have launched a PAM module.
Oh, wow.
Everybody at the pad told us we were crazy for doing it. They evacuated. That was the most highlighted thing of my career uniquely.
Right. And that was on Apollo 8.
All that, I called the program manager the next morning about 6 o'clock in the morning after our test results came back, cleared for launch to go to the moon for the first time. So that was a very emotional thing for me. And it showed that, hey, people at NASA were paying attention. People were looking at safety critical issues. Had that switch had that problem, it would have destroyed the vehicle at launch. So we had a very, very good system level safety, training, organizational flow. The next biggest thing I think at NASA was with the Apollo 13. I was involved with that. There were two stations. There was operations and there was engineering. I was on the engineering station. I was there at some late night and was the only person at the station and heard the call, Houston, we have a problem.
Wow.
We have a master alarm. The master alarm system is part of what caution and warning. I had the displays and control system. So anytime a caution and warning came up, I was tagged, understand, and explain to program management what that meant. So we had the oxygen tanks and we had all types of sensors setting issues. And that period of time for the next 4 or so days was just an amazing work effort on everybody's part, working together as a team to make this thing come back home. It still resonates as to when you see the movies or you hear about this, it's only a fraction of the emotions. There was so much more going on.
Right. I mean, when you see a movie, it's only a glimpse. It's an hour and a half, when you are actually there. Like you said, it was 4 days of emotion, of stress, of problem solving.
Days, one of the oddities was that I was told by the program manager that we had Walter Cronkite wanting to interview me because I had the system that defined the problem. So I spent those 4 days hiding from Walter Cronkite. But that was things you remember.
Right, exactly. Did he ever catch up with you?
No.
Okay.
I was now thinking that I was not interested in publicity.
Right, exactly, yeah.
And as a result, I was part of the team that received the Presidential Medal of Freedom for the recovery of the spacecraft. So it was worth every effort.
Yeah, absolutely. No, that's amazing and very heroic and effort. Congratulations. That is amazing.
But in additional to that, at the shuttle program, during that same period of time, I was put onto the shuttle program and was a program chairman for the integrating avionics system. I led the team that integrated the shuttle vehicle avionics, which was 5 computers working simultaneously with fail safe requirements. And we built that system to be safe. We built that system with integrated technology that was not existing until the shuttle came along. And that's over 50 years ago. And today you look at this and you say, hey, we got computers now that are magnificent. Back then we were running on 64K machines, 10K machines, 8K machines.
Right.
Not the same language. Software is different.
Yeah.
Systems change. As we see now, technology is improving the capabilities of doing forensic analysis, for example. And we're seeing that throughout the industry. And as it evolves, so will safety. NASA also provided me with the integration aspect. I became the project engineer for the payload integration, where we brought all the payloads from all over the world, meeting people and talking about their systems and integrating them into the shuttle program. Gave a wonderful overview of international issues and the way people deal with public. So gave a good grounding, a good base. Now, at the end, I was involved with safety. I was at level 1 safety, so the space station, level 1 safety concept was part of the team I worked with when I left NASA. While at NASA, I had permission from NASA to do consulting work. So this business started with the philosophy of NASA and the timing of NASA allowing us to do the things we can now do right in our activity.
All right. Yeah. Having worked on some of these iconic aerospace missions, how did those lessons prepare you for transitioning into accident reconstruction and litigation support?
Well, that's what NASA did, basically. They designed, they tested, and they verified the activities of what the space station did, what the shuttle did, what the Apollo and Gemini Mercury. They were systems oriented. We had teams from different disciplines that we had to present our facts to, or our changes to, or our ideas with. It was a very open environment for discussion. People listened, people would argue if you didn't like what you're seeing, but it gave us an overview of people, attitudes, how to take a system and look at it from all aspects and to determine what is the best approach to dealing with the issue. And that's
Right.
what I built my company around, is the integration of facts to look at what we have, not only as a singular direction, but the whole picture. What does it mean? How does it all play together? How do you come up with a solution that makes it safe? How do you make it work?
Yeah.
How our philosophy has been, and it's a standard feature for our business.
Now, I know you founded ATA Associates while you were still working at NASA, long before forensic engineering was recognized as a field. What inspired you at that time to start your own firm, and how did NASA's system thinking influence ATA's methodology? Tell me a little bit more about that.
Well, I had a call from an attorney on a boating case that a person in a bass boat was thrown out of a boat. It's called a stick steering bass boat, where you're sitting in the front, almost in a crucifix position with a throttle and a steering above the gunnels. The person was thrown out, was killed in an incident. I was asked to see if I could become an expert to understand the operations of this boat. And it was right along the lines of testing human factors, which is part of control system design. So we started instrumenting boats and testing boats and showing the dynamics of the boats. And part of that came as a result of people being killed and trying to prevent accidents. And the biggest thing from that version of time, about 1979, 1980, we had a series of Supreme Court judgments on kill switches. On a boat, there's a kill switch that stops the engine if you are incapacitated.
Mm-hmm.
I and one other gentleman were premier in convincing the injury industry that you do this and create safety. That's Bailey versus Boatland case. So kill switches on boats, absolutely safe way of doing business, have been incorporated as a result of our accident reconstruction. That's one example of how we put it together using NASA's influence, doing right things for safety.
Right. Now, ATA handles everything from trucking and boating accidents to petrochemical explosions, aircraft incidents, and international investigation. What core philosophy guides your approach to uncovering the truth in such diverse and high stake environments?
We get big cases, we get little cases. We get generally a case a day or more. And we have done that for a number of years. We've had over 7,000 cases that we've accepted. What we have is a philosophy. You do it right, you do it the same way each time, and you deal with trying to find the answers and what is the resulting issues so that the truth is out there so you can understand what you have and how you apply it to the issues in the case. And that's systems level. That's taking consideration factors that are going to mitigate this issue and be broader than just the actual issue. There are subsets of that can be influence the avoidance of that in the future. So we look at it from a safety standpoint, we look at it from a system standpoint, we look at it from a technology standpoint, and you apply the technology to make that equal the resulting decisions process, which is safety.
Right. Yeah, and safety underlying all of the different transportation methods and modes. So it's similar, I guess, technology and process throughout the different types of accident reconstructions.
It's getting more and more complicated because we have data that has been added to trucks and cars and vehicles that record what's going on.
Right,
You have to look at all that. No longer is it just two aircrafts laying on the ground. You have all that information internally embedded in the vehicle for reconstruction, which needs to be very carefully analyzed and looked at and not interpreted improperly.
right, exactly. Now, your facility is housed in NASA's former Life Sciences building, and it's one of the most advanced forensic engineering test centers in the industry. How does this unique environment elevate your team's capabilities compared to traditional forensic firms?
We've had 50 years of experience and activity, and we've kept the technology internal to our facility by keeping what we have worked on and building our base. We have instrumentation, we have test facilities, we can crash vehicles inside our facility. We've modified the concept of crashes by internally moving vehicles on rails so we can get dynamic information and data in crashes. We have technology here that says the highest power density building in the Clear Lake area. We have 20-ton cranes, we have car lifts, we have generators, we have compressors, we have laboratories, we've got graphic areas, instrumentation, analysis areas. So we've taken this technology that's available and built into our facility a end-to-end capability of taking data from an incident, analyzing it, projecting it into graphics or animations or something that the court or people can understand, and presenting that information forensically in a trial environment in front of the juries. So
Right.
it's an educational process. We have to educate the jury. We use the technology and advancements of technology, which are severe right now because our technology is changing significantly.
Yeah, so quickly, especially with AI. Are you integrating AI into your systems and
It's
right
amazing.
now? Hmm.
We have, we're not, I'm going to say we're not there yet. We have been using it for months now and we are learning it. You need to understand it and appreciate its capabilities and limitations, but it's wonderful. And as it grows, as this database extends itself, it is going to be invaluable for looking at things. For example, if you have a car accident, in the databases, they keep all that at the federal government. Now that's going to be integrated so that you could ask AI, how many rear end collisions in this kind of environment have you seen?
Oh, wow.
It would be a great analysis tool
Yeah,
to understand whether we're seeing something that is one of a kind or unique. So it's not something that we understand totally yet because it's in its infancy. I
right.
believe we're going to be driven by it. I believe it can be misused, but I believe if it can be used properly, it can be an absolutely wonderful opportunity.
Yeah, I would think so to really help you analyze the data, process the data a lot more quickly and efficiently, and like you said, compare multiple databases.
And what's
And yeah.
happening, when we talk about the early Apollo days when we started this business, there weren't computers. There weren't, I went to college and I used a slide rule. I never had a calculator. College and we went into an environment where the Apollo had a 8K memory, K memory, then a 24K memory. That's not much in the way of your iPhone has a terabyte of memory.
Right. Wow.
It's
Yep.
not the world anymore. As a
Yeah.
result of that, each of these terabytes of information are now goes into a database which becomes massive.
Hmm.
Getting into there and mining that data, changing that data to be realistic is a risky, but it's an interesting and it's a part of what we do. We have to look at it. You have to come up with an objective answer. You have to come up with what it says, what it looks like it says. Yeah,
Exactly. Yeah.
it be interpreted. So that's be part of being an expert is being honest and being representative and knowing what you're doing and making sure that you apply science properly.
Yeah. Now at ATA, you're blending engineering expertise with the advanced instrumentation, 3D scanning, drones, animations, simulations, and testing. How has this technology changed in what's possible in accident reconstruction over the last few decades?
When we first started, we had what they call a total station, which is you get out there with a pole on the ground and you stand by, and someone with a surveying device will get you a plot of the landscape of the accident, and you record that and you make a drawing. Now it's we go out there, we can put a Faro scanner, which is a laser scanner, scan the whole area. It takes a couple hours. We'll have a complete 3D model, dimensionalized and available to make operational decisions around. We also have the capability of then taking the vehicles that we can scan and take the damage patterns, put that into software together with the drawings of the site. And virtual crash, for example, will allow us to run models to talk about the crush damage, speeds, impacts. So the technology is sort of building itself around the need to understand the detailed analysis of events, and that's improved tremendously. And I see in the future the concepts even getting better. But we just recently purchased a handheld scanner.
Mm-hmm.
Gives us resolution to like a 16th of an inch, and we can model anything, scan anything, and it just absolute technology. If you keep up with it, has changing characteristics that make our business much more scientifically correct.
Yeah. So a lot more, I mean, better precision, I'm hearing. The tools are probably to do work a lot more thoroughly and quickly as well, saving a lot of time and just get a lot more dimension and information. Yeah.
That information now is all digital. Now
Mhm.
sent off to the cloud. It can be organized, and when we go to a trial or have a deposition, we have to exchange that data. It's a database that is organized, structured, and has supporting information that can be, I'm going to say, satisfactorily accepted by trial. Trial has a Dahlberg-Robinson rule that says you have to follow science, follow technology, use the right approaches, recommendations, use the right standards, follow the right protocols. That's strict from the court standpoint. So everything we do has bounds around it that talk about reliability, talk about safe ways of doing business, and you as an expert have to be extremely sensitive to being honest, because they're going to try to trap and destroy you if you don't.
Yeah, that's a good point. Now, you've worked on high profile cases like Exxon Valdez, Deepwater Horizon, major petrochemical explosions, and even the investigation of the Polish president's aircraft crash. What consistent patterns do you see in catastrophic failures, regardless of industry?
Someone somewhere made a mistake and didn't follow the rules. It did something different than was expected. And some of that could be a hardware failure, some of that could be a software processing failure, somewhere it could be a personal failure, some could be just the ideological aspects of the way people treat accidents. Bigger companies are very attuned to looking at big picture. Smaller activities, they only want to focus on elements. So the technology allows us to go to the level necessary to prove our case or disprove the case, but we get an honest answer. So what we're looking for, forensic engineers are looking to look at the facts, put them together, be objective, and give an answer. It's not a solution, but here's what the cause was. And
Right.
here's how you can correct that. Because an expert, if they say, hey, it should be corrected, you have to come up with a way to make it correct. So they require you, if you say it's a defective product, what's the alternate? So it's not a matter of just pointing at something and say, hey, you're bad. If you say it's bad, you got to have a conclusion to make it. So it's an environment that's very specialized, very rigorous, and there's a certain set of people that can do that.
Yeah. And I'm guessing that the information that you find then goes on to inform companies on how to improve, products or systems or, create safer automobiles, et cetera.
Absolutely. And I think as a result of the start of this, OSHA was established. There was no OSHA when we started activities of forensic work.
Uh-huh.
And they are now looking over things like this and trying to prevent that. And the inspections and the criteria that has evolved from that has improved the quality of life for operators or laborers, as well as companies from the standpoint of recognizing that if you have a problem, you got to change it. You got to change your ways. You got to change your machines. You got to do something to make it work right and safe.
Now, the litigation environment, especially around trucking, petrochemicals, and marine incidents, has evolved dramatically. What major shifts have you observed, and how is ATA adapting?
Well, we have a thing called a bottomless pit here in automobiles and trucks, for example, and it also includes aircraft and marine. There's onboard electronics, and for each one of these electronics, called black boxes, there's a device that you have to connect to it and software you have to connect to read what is being said. That technology has changed over the years where we're getting more and more information. We're getting data that requires computation and software analysis, but it gives us more depth of information that we aren't, as experts, creating. We are applying facts. The facts are all digital, the facts are all on a recorder. So it's no longer a theory of what happened. There's more of a proof of what's happened, and you can stand behind it with a higher degree of reliability. And as instrumentation improves, as computer processing improves, that data is going to improve. So we see the change of technology with the adoption of AI, with the hardware integration, safety, and cameras everywhere. If you have an accident, we see a camera view of it generally because of some restaurant or some association or vehicles having cameras. So
Right.
proof is based on fact now, not just like in boating accidents, you have a collision between boats. There's no marks or anything on the ground. In trucking, you can understand with GPS where they're coming from, their speeds. You can look at the damage pattern. It makes this a scientific analysis, and it's
Right.
a big difference than trying to look at it and use your knowledge to say, hey, this is probably what happened. When this now happens, you know what's happened. You know how the issues are. It's technology is improving knowledge.
Yeah, exactly. So you have a lot better informed results based on actual scientific data or video or other tools that give you facts that before you might have been, deducing, and making educated guesses. But
I also add one thing to that. We're seeing that the enforcement officers, the police officer, Coast Guard, the people that are out there doing the initial assessments are much better educated and have had training.
okay,
As everything is building, so
right.
builds the results into a much more believable operation. Now, using that information properly
Hmm.
to apply safety, to look at this as a learning curve. One of the reasons we do this, or I do this, every day is a different day. We see something new every day, but the facts that we know of causing things tend to repeat themselves. They may have repeat themselves differently, but the history that we've gained over the 50 years is amazing. We just had another boating case come in this morning, a pipeline, a boat running over a submerged pipeline, and we had dozens of these. Propeller shaft hits the engine, breaks the mount, and the engine comes into the boat, still running, and hits
Oh no.
the operator, and it's not a pretty sight.
Right. Wow.
So there's history. Now, that's a repeated history over 20 or 30 years of experience that
Yeah.
had the same failure. Now, what's going to happen in this case? It'll be interesting.
Yeah. Right. So when things repeat like that, then you'd think that they would put safety measures in place so they wouldn't repeat. Why isn't that the
Yes,
case?
but then somewhere that's a very complex, dynamic situation. Speed of the boat, where it hits the drive shaft, the skag of the engine. So it's a complicated story. But the mold that holds that on the frame It's supposed to have shock absorbing capability to a certain level, but if you're at a high speed and you hit it the right way, dynamics can be very significant.
Right. Yeah. Very interesting. Now, your work demands speed, precision, and an ability to mobilize anywhere fast. What operational capabilities does ATA have today that simply weren't possible when you started?
Hmm, that's good. We have 4 vehicles set up in our facility, each loaded with equipment, so that we can respond immediately to a request, so that we're quick response teams are ready to roll. Those are loaded with scientific. We have also support capabilities when we get a case. We bring in Pharaohs or other technology that require drones for the site operations. So this new technology allows portability. We use, in some degree, we can carry my iPhone. I could do 3-dimensional photographs and animations and replace a $60,000 Pharaoh with my iPad phone here, if you will. And it does the same basic capability. So we're seeing technology reducing price, technology increasing capabilities, and it's a matter of innovation. In the future, we're going to see innovations that even make it even better. But there is science that is applied to this that is really helping the growth of forensic analysis.
Right. And with technology advancing and systems becoming more complex, what new types of failures or investigations do you anticipate becoming more common in the coming years?
Well, you get deeper into it because you now look at variations. If you have electrical power interface to a ATV, for example, you have the charger that's on the ATV, which produces heat. You got power fed to that, which could be a power cord that could or could not have the right sizing. Where does it occur? If a vehicle catches on fire, what is the causation? When you sit there, we see a case of ATV catching on fire in a garage, burning the facility down, and there's nothing left but rubble. And you look at it and you sort of decide to yourself, what caused that issue? And the vehicle is destroyed, but you have the systems. So you have to backtrack. You have to build a story based on what the actual unit has in design, where they put the charger, whether there's a thermal issue there, whether there's a grounding issue. It gets very complex. And what you can't do in a situation like that is prejudge it until you understand. And the manufacturer is going to be requested to provide us knowledge and provide us data that we can understand and become more appreciative of what that fire cost was.
Interesting. So yeah, it's just being cognizant not to make assumptions prior. Don't make judgments, like you said. Let the data speak for itself, really.
And it's not just data, but there's a lot of features to an event that some people like to say, hey, I got a ground plug. It wasn't attached, therefore it's the cause. But there's many other factors that deal with the situation that need to be evaluated completely before you say yes or no.
That makes sense. Yeah. Now, forensic engineering requires not only technical expertise, but communication skills, courtroom presence, and the ability to perform under pressure. What qualities make someone truly great in this field?
It's the ability to express yourself and ability to understand. Let me say this is not a kind environment because you're being hired by attorneys to destroy other attorneys. If that's one thought process. There are competitive answers because there's an attorney on one side and an attorney on the other side. We build a story, but in order to stand up, you have to be able to express yourself. You have to have the demeanor. You have to have the knowledge. You have to have the experience of understanding the court environment, understanding the litigation environment, understanding the technology associated with the science that is used to make the answers. So it's a much more complicated environment. It takes someone years to develop that knowledge.
Right.
And knowledge can be applied. Once you get into this forensic world, it's a very, very interesting, but it's also very complicated. It's also can be called out anywhere, anytime to do anything. It's very compensating because mentally it keeps you alive.
Yeah, I can imagine. Now, in these court cases, are both sides hiring expert witnesses
Yes,
typically? And so you're having to present your results based on your accident reconstruction analysis, and then the other side has another firm that's doing the same thing.
there are multiple. It's not uncommon to have a half a dozen people involved with a case.
Uh-huh.
Generally, the experts work together very well. They may have different opinions, but everybody in our business sort of is accepting the fact that they recognize you as someone that has the capabilities. There's not that many people out there doing this.
Oh, interesting.
Those
Okay.
that are out there, it's a small community in that regard. Everybody knows each other's companies.
Yeah.
Generally speaking, we work together well.
Now, with the improvements in technology, are you finding that your results are more similar with
Yes,
other firms now?
yes. It
Yeah.
narrows down that the focuses in on what the specifics are.
Uh-huh.
Specific may be someone from a vision standpoint. We could see this at 450 feet. Do you have time to react? We can narrow down the margins of visibility or timing or braking to whether it's a vehicle problem, an operator problem, boat problem. So it narrows down the responsibilities and narrows down the answer to a point where technology is used to establish facts.
Yeah, exactly. Now, many engineers dream of becoming expert witnesses or landing or leading high stakes investigations, but don't realize how long it takes to build that credibility. Like you were saying, it's a long process. What guidance would you give to someone early in their career who wants to follow this path?
Make sure that you have a broad base. It's not something that, in dealing with this, if you're going to be an expert witness, if you're going to be a person that is going to expand their background, you have to have I'm going to call it a worldly look and appreciate what's going on in the science, what's going on in transportation, logic that people feel, politics of the environment, because there are goals to be safe, goals to be correct, but there are people and there are elements out there that are going to fight no matter what you say. So you're going to have to stand up to your rights. You're going to have to present yourself in a strong, compelling manner. That's why we have animations. That's why we have graphics. That's why we put simulations together. You do it in a way that you're educating. So if you're going to be an expert, you got to look at the capabilities of not only looking at an accident, but presenting it in a sophisticated way to a jury, which is a set of individuals that may have various degrees of education and background. It may not
Right.
appreciate science. So you have to dumb it down, make it good, and show people what it all adds up to.
Yeah.
That doesn't take, it takes a broad range of system level appreciation to be able to do that. And also you have criteria. They examine us when we get a deposition notice. I can guarantee you that they will run a background check on everybody and understand if you had any issues, they're going to bring it up.
So they're
So
looking at your personal credibility as well as your experience and your education.
and the courts are very arbitrary on how they make those decisions. So sometimes it's not necessarily logic.
Yeah, subjective, I guess, and according to the case. And
That's another word, yes.
yeah, yeah. Now, after 5 decades of leading ATA, what excites you most about the future of engineering, safety, and failure analysis? And where do you see the greatest opportunities for innovation and impact?
Well, I think the technology is making our job credible. When I say credible, we're no longer built on subjective thinking, we're built on facts. It's a matter of building those facts into a story efficiently and effectively. Animations, for example, when we initially started, I think the New York Times wrote an article on us 30 years ago with one of our cases, which is an asteroid case. We're the first animation that was used in trial. That technology would be something in the $50,000 to $70,000 range just to make an animation of a roller coaster ride.
Yeah,
That number has come down, and we can do that for less than $5,000 now and have a better product. So the concept of technology has increased our capabilities, reduced the efforts, and made the product much better. And we see with AI, and we see with it every year, we see a change in the ability to see more information, collect information better. As we see AI coming, there is going to be part of this LiDAR and droning of sites. We don't necessarily have to be there. We can go onto the internet and look at the Google Earth images, and that can save us from going to sites. It's amazing that we can go to a site. We can also go in history. We were looking at one yesterday on an electrocution case that the attorney asked us to look at. They were digging a hole, and they checked to see if there's any power underneath it, and the people putting a pole in the ground were electrocuted as a result of a misplacement of a power wire.
Oh, wow.
That attorney gave us the case. Our expert looked in the file, and in the file was work being done at the site of the event. So you never know what's going to be on the internet. You can find police officers' reports, press releases. It's all coming into a focus. This communication, this international, worldwide communication links where you don't need to be anywhere. You can do it all by phone. Is the same thing is happening with engineering. We can do things remotely. People have done it before. We can collect it. We utilize it. It's keeping up with Joneses, if you will, so that you keep your technology at the level necessary to be competitive.
Yeah, and being at the forefront of that technology, and like you said, the more technology evolves in other ways, it's giving you even historical data and repository of information and video, etc. That's fascinating. Well, Bob, thank you for sharing your story and the extraordinary work you've done across aerospace, forensic engineering, and accident reconstruction. For listeners who want to learn more about ATA Associates, where can they find you?
Here in Houston, Texas, we have a facility next to NASA Johnson Spacecraft Center, 1301 Gemini, Houston, Texas, 77058. We're here, ATA Associates.
Awesome. And what is your website address as well?
It's ataassociates.com.
Thank you. And for those listening, if you enjoyed this episode, be sure to subscribe and join us next time. Until then, stay bold, stay curious, and keep igniting industry.